we're going to go dive into problem number 2, adding 2 numbers in a linked list, which is medium difficulty. Oops, sorry, I should probably delete my stuff before I start a video. My bad. So it says you are given 2 non-empty linked lists representing 2 non-negative integers. So non-empty and 2 non-negative integers. The digits are stored in reverse order, meaning that 3 should be first, 4 should be second, and 2 should be last. And each of their nodes contains a single digit, so 1 digit for the value. Add the 2 numbers and return the sum as a linked list, meaning I'm going to add 4 and 3, I'm going to add 6 and 4, and I'm going to add 5 and 2. So you may assume that 2 numbers do not contain a leading 0, except for the number 0 itself. So we'll dive into the first one. First one's a little bit unique, so we're going to reverse these. So 3 will be first, 4 will be first, 4 will be second, 6 will be second, and then 2 will be last in this one, and 5 will be last in this one. So let's go ahead and add these two. 4 plus 3 equals 7. So since it's reverse order, we'll have 7 right there. 6 plus 4 is 10. So since we got a 0, so we'll have to have a carryover, because you see that 5 plus 2 does not equal 8. 5 plus 2 equals 7. But since we have 10 in that first one, we'll have to carry that second digit of 10 over to the next node and add it here. So 5 plus 2 plus the 1 from the previous computation will be 8. And it's similar for a longer input as well. So yeah, so the number of nodes in each linked list ranges from 1 to 100. The values of each node will be 0 to 9, and it's guaranteed that the list represents a number that does not have leading zeros. So we'll have to instantiate a couple of variables, one of them being a head where we can start, like a dummy variable, I guess you could say, and then we'll probably set that to a more readable piece called current, so we can set a current node that we'll assign values to, and then we'll instantiate a carry variable that will end up representing a sum that we can split apart at the end if it's necessary. So let's instantiate those. So we'll first put the dummy head where we start with linked lists. So we have to start at the head to traverse a singly linked list. So we're going to instantiate that value to 0. As you can see up here, it has a list node that shows you how to instantiate it, so on. And then we'll do that current variable. It's just going to equal the dummy head. And then we'll let that carry equal 0 in the beginning. So we're going to go through for a loop and then put a couple conditions there to keep it in the loop until the end. So while list 1 is not equal to null, or not identical to null, or list 2 is not identical to null, or carry is not equal to 0. So moving forward, we're gonna put this carry equal to the sum. So I'm gonna make it a little bit more readable. I could do this later, but earlier, but I'm not going to. So sum equal carry. So that just means in the end, the sum is going to be the carry that we can split apart if necessary, like I said before. So we'll do a couple conditions to add the two variables. So we instantiate a sum. So for the first list, we're going to take the list if it's not null and add the sum to the linked list value of the first element. So sum is now equal to essentially the value of the first element. And then we'll move on to the next element in the first linked list. So linked list dot next. So that way, next time we come through, list 1 is dot next. So if it is ever null, or if you go off the end of the linked list and it does equal null, we'll break out of the loop. So we'll kind of do the same thing with the next next list. So add that sum as well to the value. So now the sum is equal to L2 plus L1, easy enough. And then we'll do the same thing where we instantiate L2, list 2, to the next variable in that element, or that next element in the linked list, sorry. So now what happens if the carry is double digits, like 10 or whatnot? What we'll do is we will split it apart using some modulus functionality. So what we can do is we can divide the sum by 10 so that it's evened out, and then we can create a next node excuse me, with the sum of modulus 10. So we can use 10 as a base number to split apart those two elements into two separate numbers. So I'll kind of show you how that works. So I'm going to use the carry, and I'm going to do math.floor, so in case it's a little bit of a wonky number, and I'm going to divide the sum by 10. So it's 11 divided by 10, it's going to be 11 over 10, or whatever that decimal comes out to be, but it's going to be the floor. So most likely it's going to be a full number. So moving on to the next piece, we'll have the current dot next. So notice how we set current up here, which is the dummy head. We're going to set current dot next equal to a new list node. So we're creating a new node because we have to put that carry onto the next piece, onto the next element of the array, or of the list. So we're going to create a new list node that is the sum modulus 10, which essentially gives you the remainder of the sum divided by 10. So this gives you the first digit, this gives you the last digit. Because for the most part, the largest number that you'll be getting is 18. So it's always going to be, most of the time, this first number is going to be 1. And the second number could be up to 8. Because if we have 18 modulus 10, 18 divided by 10 gives you the remainder of 8. With this sum, if you do 18 divided by 10, when we do math.floor, it's going to give you that first number, which is 1. So we'll move on into the next one, and then we're going to set current equal to current dot next, and then it'll continue to go through the loop until the end, when one of the elements or one of the lists go over where the carry is not equal to 0, and then since we've built a current dot next or dummy head, we've added some more nodes to it. What we can do is we can return the dummy head dot next, and that is how we do it. So we'll go ahead and run this, make sure it works. And as you can see, we've got 2, 4, and 3, 5, 4, and 6, and the output is 708. And then if we submit it, we can see that it took 3 milliseconds. It beats most of the people. It doesn't beat all of the people that have done this this problem, but it does pretty well. The big O is going to be O of n because it has to go through each element of each array or each list. So n is equal to each node in the lists. So technically it would be 2n, but because we dropped the constants, it's just going to be O of n. So there's a solution, and that is it.